In this video, we're going to discuss the equation of a circle. Let's make sure we understand what exactly a circle is. So a circle is defined to be a set of points in a plane that are a given distance from a given point. And this given point is called the center of the circle. Now the center is not a point on the circle. So for instance, you could look at the set of points two units away from 0, 1. So for instance, 0, 1 is here, okay? And then you look at the points that are 2 units away. Well, you can look at the points that are 2 units above, so that's 0, 3. 2 units to the right, that's 0, that's 2, 1. 2, 1. 2 points down, so that's 0, -1. And 2 points to the left, that's -2, 1. But then you also have points that are 2 units in any direction. So you have 2 units like in this direction, 2 units that direction, 2 units in that direction, every direction. And if you, maybe this point should be closer, like here, -2, 1. So if you plot all the points that are 2 units away, it's going to look like that. So the points that I just drew, that's the circle. That's an example of a circle. So a circle is, there's always a distance and the point. Okay. And so 0, 1 is the center of the circle. 0, 1 is the center of the circle. And this number of units away is called the radius. So there's actually 2 uses of the word radius. So a radius of a circle is any segment and any segment with the center and a point on the circle as endpoints. So for instance, if you take the circle in the example, you have the center and then you take a point on the circle like that, line segment, that's a radius, the line segment I just drew. You could take another point on the circle like this point and then connect that with the center, and I just drew a different radius. So that's 2 different radii, the plural is radii, of the circle. Okay. But, so that's the radius as a line segment. But the word radius can also be a number. It can also mean the length of that line segment. And the length is a number, right? So in the example above, the radius of the circle is 2. So instead of the radius being a line segment, it's just 2. That's another way to use the word radius. Similarly, there are 2 ways to use the word diameter. So one way is to refer to a diameter as a line segment. A diameter of a circle is any segment that passes through the center of the circle and whose endpoints are points of the circle. So if you have this circle, say that's the center, then we're talking about endpoint segments that go through the center, but the endpoints are on the circle. So that would be a diameter. You can have something like a horizontal line segment like that. That would be a diameter. Or you can have vertical. That's also a diameter to go through the radius. That's also a diameter. Okay? So, but it can also refer to the length of that diameter. So in this case, in the example above, okay, a diameter would be like this. That would be an example of a diameter. And then the length, well, it would be 4 because there's 2 units and 2 units make 4 units. The diameter is always 2 times the radius. So those are some definitions. It's important to keep in mind that the way we're using the term circle, we mean the points that are exactly a certain distance away from the center. So for instance, in the example that I just drew, if you take this point here, that point is not on the circle. Okay. We would say that it's in the interior of the circle, but it's not a point on the circle. What are the points on the circle? They are the points that are exactly a fixed distance away from the center. So these points that are in white, these points are on the circle. The circle consists of all these points. Those are the points on the circle. Let's look at an example of finding an equation of a circle. Find an equation of the circle with center C, which is 2, 4, and radius 2. Let's draw a picture of what that circle looks like. So the center is 2, 4. That's the center, and then the radius is 2. So let's go out 2 units to the left and right and up and down, and the picture looks something like this. Okay, that's not a great picture, but it should look more circular than that. Well, so what we're trying to look for is we're trying to find an equation involving x and y. So let's say you have a point P, which is x comma y, and it's on the circle. So suppose that P x comma y is any point on the circle. What we're looking for is we're looking for an equation that x and y have to satisfy, so that if, first of all, it has to satisfy it if the point x comma y is on the circle, and also if your x and y satisfy that equation, then the point x comma y is on the circle. Okay, so it's, yeah, So x comma y is on the circle exactly when the equation is satisfied. That's what it means to find an equation of the circle. So what has to happen if x comma y is on the circle? Well, it means that the distance between x comma y and the center has to be 2, because 2 is the radius. Now how do we find an equation to express that fact? And my point C is 2 comma 4. So what equation can we write to say that x comma y is 2 units away from 2 comma 4? Well, we can apply the distance formula. And that tells us that the length from P to C is equal to the square root of the change in x, that's x minus 2 squared, plus the change in y, that's y minus 4 squared. Right? So you have these two endpoints, these 2 points, and say that they're 2 units away from each other is the same as saying that this formula is true. Well, we know that PC is 2, right? PC is the radius, which is 2. So it's the square root of x minus 2 squared plus y minus 4 squared equals 2. Now that is an acceptable equation for the circle, because this tells you exactly that x comma y is 2 units away from 2 comma 4, which is exactly what it means to be on the circle. But it does help it's more standard to square both sides, so then to write it as x minus 2 squared plus y minus 4 squared equals 2 squared. So that's a more standard way of writing the equation. Okay. So both of these are acceptable, but this one is the more standard way of writing the equation without the square root. Okay, we'll talk more about different ways of writing equations of circles later. Maybe before I go, I'll just write down the general equation. So in general, an equation of the circle with radius r and center h comma k is x minus h squared plus y minus k squared equals r squared. So notice that this is really just saying that, so I have h comma k, my point x comma y. This equation is really just saying that the distance between x comma y and h comma k is equal to r. If you just write out what you get from the distance formula, which we remember is from the Pythagorean theorem, then this is the equation that you get. Okay, we'll do more examples of this in a later video.